Hello, we are on day 7 of our STAAR review, and we are starting the topic of transformations. That will be day 7 through 9. This topic, transformations, there's going to be about 7 questions on the STAAR test, so it's one of the bigger topics for your test. Out of those 7 questions, 2 of them are going to be over dilation specifically, and then there's going to be 2 more questions that are over translations, reflections, and rotations. There's also going to be questions, maybe a question over preserving congruence and dilations and measurement. So before we move into day 7's specific notes, I want to talk to you about what's in your resources. If you look in your STAAR folder, you have that study sheet. On the back of that study sheet, you have this section right here, which is towards the bottom, the second to last section. This is all about transformations. We have a translation, which means to slide. We have a reflection, that means to flip. We have a rotation, that means to turn. And a dilation means to enlarge or reduce, which means it's either getting bigger or it's getting smaller. So those are your 4 transformations. This is where you could look as a resource in your folder for your assignments, along with the note pages that we're going to go over. So let's start with day 7, which is specifically over dilations. So dilations and scale factor. The definition: dilation is a transformation that uses a scale factor K to proportionally enlarge or reduce a figure. So it's either going to make a figure get bigger or smaller. And what determines if it's getting bigger or smaller is our scale factor. Okay? If my scale factor is greater than 1, my shape is going to get bigger. If my scale factor is less than 1, my shape is going to get smaller. That number, that scale factor, is going to determine what happens to my shape. So there's a specific rule. The way we write those rules, it looks like this. XY transforms to KX, KY. So what this means is that they are multiplying the scale factor by both the X and the Y value. So they're using KX, KY. You also probably have seen me write it like this, something X, something Y, and that number is my scale factor, right? Whenever we see the word dilation, we want to remember that it means that we are multiplying, right? Dilations multiply. So if you're looking at a question over dilations and they're saying, what is the rule for this dilation? You want to make sure your rule is multiplying. If you see any adding or subtracting, cancel that out. There's no way that we're adding or subtracting whenever we're talking about dilations. So right here, talking about enlargement or reduction. So enlargement makes it get bigger. It's getting larger. My scale factor is greater than 1. So here's some examples down here. I'm going to circle the ones that are going to make it enlarge, or we can write it up here. So for example, this one right here, 3.5x, 3.5y. This number right here is greater than 1. So it's an enlargement. This number right here, this rule right here, 0.6x, 0.6y. This is less than 1, so it is a reduction, right? It's in between 0 and 1, which means it's less than 1. It's going to get smaller. That's how you tell the difference between if a rule is going to make the shape get bigger or smaller. Some examples I want to go over are fractions. So for example, this one right here, we have 1/5 x, 1/5 y. I know that 1/5 is less than 1 because that numerator is smaller than the denominator. So this is a reduction. This right here, I have 4/3 x, 4/3 y. 4/3, that numerator is bigger than the denominator. So I know that this is an enlargement. This number is greater than 1. 4/3 is greater than 1. If you are confused or you don't understand, you can always go to your calculator we can convert fractions to decimals to see, is it greater than or less than 1? So I can go to a calculator screen. We've already done a video on how to convert fractions to decimals. I see that 4/3 is over 1. It's greater than 1. So it's going to make that shape get bigger. It's going to be an enlargement. On page 14, they talk about how to find scale factor. So scale factor is found by dividing the new over the original. I usually refer to it as scale factor is new over old. New over old. Okay, so finding the rule for the dilations below. So I'm looking at two shapes here. It tells me in this picture which one's new and which one's old. Let's say I don't know that. They don't have that written for me. I can look at the letters for the points and determine which one is new and which one is old. If we look here, I can see that this point is A and this point is A prime. This right here, since it has the prime mark, that tells me that it's new. So now I can use a point. I can pick any point I want as long as they're corresponding points, which means that it has to be the same letters, right? So I have to compare A to A prime, M to M prime, T to T prime. They have to be corresponding. So right here they use T. So T, this point right here, is at 3, -2. And T prime, my new T, is at 6, -4. So this is my old, this is my new. Now to find scale factor, we do new over old, right? That's the ratio I'm gonna use. So they're using their X value, so I have 6/3, and then I simplified that to 2. I can do this with any point. So let's say I'm gonna do it with point A, just as an example, okay? So A, right here is at 2, 2. And A prime, my new A, is at 4, 4. If I'm looking for scale factor, I'm going to do new over old. I can use my X values. My new X value is at 4. My old X value is at 2. I can simplify that. 4 divided by 2 is 2. So that's my scale factor, 2. And then I would write my rule. 2x, 2y. I'm always going to do scale factor X, scale factor Y. The other thing I want to talk to you about dilations real quick before we end our video today. Dilations do not preserve congruency. That means it does not keep it the same size or the same shape. So for example here, my shape got bigger. It's an enlargement. Since it got bigger, it's no longer the same size. So it does not keep it congruent to the original shape. This is the only transformation that does not preserve congruence because it changes size. You will complete the Google form for your assignment for today.